Hello, everybody. Welcome to the 2021 Future City Theme webinar. My name is Jake Williams, and I'm the program manager for the Future City competition. We want to thank you for joining us for our annual topic webinar today. As you probably know, this year's Future City theme is called A Waste-Free Future, and it's all about designing a, as you might imagine, waste-free city that uses the principles of a circular economy. This webinar is an opportunity to hear from a panel of experts who have real-world experience with the concepts of a circular economy. And by the end of the webinar, I think you'll have a lot of material to inspire and to expand your ideas and solutions about this year's topic. We are using the Zoom webinar platform for today's program. If your sound quality is not good, you can switch from using your computer's audio to calling in by phone or vice versa. To switch your audio options, just select the button next to the microphone icon. The full recording of this webinar is going to be posted in the public resources section of futurecity.org later this week. Also, there'll be a short survey. It's just 2 questions. It's very quick that will pop up when this webinar is over. So please take a moment to complete it because your feedback really helps us to continuously improve the content that we're providing. It really is useful for future things that we make to be as useful to you as possible. To ask a question, just type it in the Q&A space on your control panel. My colleague Maggie Dressel, who's the Future City Senior Program Manager, is on the line and she's monitoring the incoming questions. So if you have any questions throughout the webinar, just type them in at any time. And after all 3 presenters have spoken, they'll answer as many questions as we have time to get to. Also, just as a reminder, the focus of this webinar is on the theme, the challenge this year. So if you have any technical questions about the competition itself or the deliverables, you can visit the frequently asked questions page for educators on futurecity.org or check out the resources section of your dashboard. Or you can email info, I-N-F-O, at futurecity.org with those types of questions. Let's keep today's questions on topic about this year's circular economy challenge. Before we get started, I wanted to mention Discover E, or Discover Engineering, which is the organization that runs and organizes the Future City competition. In addition to Future City, Discovery has a lot of other programs and free resources for educators and for students and for mentors. If you're looking for classroom activities or career information, engineering videos, all types of other content like this, be sure to check out our website, which is discovere.org. The Future City competition wouldn't be possible without the help of our great sponsors and partners, so I want to thank them for their generosity. In addition to Discover E, the Bechtel Corporation, Bentley Systems Inc., and Shell are all final sponsors whose contributions to the program makes Future City possible, not just the finals, but also webinars like this. Future City is also made possible by the support of our program sponsors, who you'll recognize as sponsors of special awards at the regional competitions as well. They are ASABE, American Society of Agricultural and Biological Engineers, NCEES, the National Council of Examiners for Engineering and Surveying, and PMIEF, the Project Management Institute's Educational Foundation. We have a great panel of experts joining us today. Dan Koval from Bentley Systems will be hosting the program. And we've got 3 experts who are looking forward to talking with you about the work that they do, why it's important, and how it fits in with what you're doing with your Future City projects this year. I'd like to start by introducing our host of the webinar, Mr. Dan Koval. Currently in his 14th year at Bentley Systems, Dan has spent the last 4 years managing corporate initiatives programs. A graduate of Leadership Chester County, Dan has had the opportunity to help numerous nonprofit organizations, not only locally, but also globally. In the past, Dan has mentored 8th grade students at Lionville Middle School for their participation in the Future City competition. Thanks for being here, Dan. Take it away.
Great. Thank you so much, Jake. And thank you to our distinguished panel of professionals that are in the real world and are going to educate us all into this circular economy and how we can have a waste-free future. And thank you as well to the mentors and educators that might be here, and especially to the students. I can't explain how excited I am for you students and for this year's theme. And so I want to get right into it. And so up first, we're going to hear from Dr. Zinette Baz, who is an assistant professor of sustainable food systems engineering at the University of Florida's Department of Agricultural and Biological Engineering. She had worked as a senior research consultant at the Packaging Technology and Research LLC, where she mainly focused on sustainability and food loss and waste reduction through packaging technologies, and became committed to tackling sustainability issues in the food industry. Her current research addresses food loss and waste mitigation strategies and solutions through processing and packaging digitization to improve sustainability and shelf life of food systems. She is also active in various circular economy concepts and applications in the food industry, such as reusable food packaging. Dr. Baz currently serves as the chair of the Institute of Food Technologists' Sustainable Food Systems Division and as the editorial board member of the Journal of Food Science. Dr. Baz, take it away.
Thank you very much, Dan. I am really happy to be a speaker in today's talk or webinar. And I'm really excited. And I'll talk a little bit about the circular economy and what sustainability is and what that entails too in the food industry. And I'll give an example from a food industry from upcycling perspective. Of course, we can cover a bunch of different topics and solutions, but of course we don't have enough time for that. But I'll be happy to answer any of your questions. If you have any, just feel free to reach out to me through any environments, social media platforms. Thank you. Next slide, please. Okay, so as we know, when we think about sustainability, the first thing that comes to our mind is environmental impact. However, I like to show that lower right-hand side graph to everyone when I'm talking about sustainability, because it's not just environmental impact, but it's also societal aspects as well as economic development. And United Nations actually came up with these goals, 17 goals from different parts of the environmental, societal, and economic aspects. And the goal number 12 focuses on responsible consumption and production. This is important from my research perspective because it has to do with the food systems, food production systems, and anything in between. But if you're interested in sustainability, definitely go to the United Nations website and then check them out. There are several metrics in indexes and how we measure the success of those goals. So next slide, please. As you know, the food loss and waste is a huge issue. And then only in the US, just in the US, 1,250 calories per person per day is being lost due to the food loss and waste. And that means actually 21% of the US landfill is from food, and 21% of the US agriculture water usage is from just food waste. So all of these numbers corresponds to food waste. And in the US, that means 229 million tons of food is lost. And only 54% goes to waste, and 23 is recycled and eaten only 148 million, and then 3 million of that is donated. So the issue is big, and then we still have a room for growth. Next slide, please. So in order to deal with food waste, what should we do? What is the most ideal step to deal with the food recovery? And then United States Environmental Protection Agency came up with this hierarchy, and then the most viable option is always the reduction, the source reduction. So we want to reduce the volume of surplus food generated. The second option is to feed hungry people. So instead of, for example, just landfilling it and then composting it, as we see it in the news or in the solutions, the first option is the source reduction, second one is to feed hungry people, and then third option is feed animals, and then industrial uses, maybe recover energy, recover valuable compounds from them, and then compost if that's the last resort for us. And then food waste actually creates in the US 4% of the US greenhouse gas emissions. This number is 8% in the world, and 14% freshwater use, 24% landfill. So it's actually a source of huge environmental and economic impact. Next slide, please. So what is circular economy? Circular economy is one of the solutions, systems level solutions to food loss and waste, or any kind of waste. Let's go to the next slide, please. So what is circular economies? Current economies are linear, and this was a result of the previous first and second industrial revolution, and then the changes, economic changes happening in the US, in the world. So this approach is actually taking the resources, extracting resources, making products out of it, using and disposing it. But in the circular economy, this is actually not a new concept. This is based on biomimicry, industrial ecology. So there's different schools of thought, but the idea is to waste nothing, right? So waste is becoming a food for some other system. For example, instead of wasting food, we are actually using it for bioethanol generation. We're using it to feed animals. So there's no waste, ideally, in circular economy. Next slide, please. So the current circular economy initiatives have been popularized again by the Ellen MacArthur Foundation. So in circular economy, we have on the right-hand side, the technological cycles. So that means reuse, refurbish, recycle, remanufacture, maintain, and extend the lifespan of the systems. And Uber, for example, is a sharing service and an example of a circular economy solution. So on the left-hand side, that's the biological cycle. That means the biological components such as food or any other biological samples or materials. So it becomes biogas instead of wasting anything. We, for example, use anaerobic digestion systems, and then nothing goes to waste ideally. And so energy recovery and landfill are the last resort. Next slide, please. So one researcher in Europe came up with the idea of different strategies for circular economy: refuse, rethink, reduce, reuse, repair, refurbish, remanufacture, repurpose, recycle, or recover. So those are ideal solutions for us. Next slide, please. So this can be quite confusing, but there are several approaches to food waste. For example, recycling them, or maybe reducing them are some of the circular economy options. So you can actually tackle different strategies to address the food waste. Next slide, please. So another way to create actionable plans for circular economy, you can regenerate, you can share, you can optimize systems, you can loop, like in the case of recycling, virtualize instead of, for example, using physical products or systems such as networking and presentation tools like Zoom is a virtualization example, or Exchange, for example, developing, improving our systems to be more digitally integrated. Next slide, please. Very quickly, I'd like to mention a bit about upcycling. Next slide. So upcycling is identified as one of the biggest benefits and has the opportunity to 1.9 million food waste tons diverted. Next slide, please. It's a culinary option to food waste. So for example, those are the examples that are made from normally considered waste. For example, the Nescafé Natif on the left-hand side uses the coffee husks and hulls to produce drinks. On the left bottom hand side, it's okara flour, a soybean production, and then a tofu production byproduct is actually used as a flour for example, gluten-free flour. Banana, for example, uses the bananas or waste bananas from supermarkets to make snacks. Toast actually uses scrap bread samples and then make beer out of it. So there's tons of examples in the supermarket. Next slide, please, very quickly. So we have different challenges. Maybe I'll just stop here after talking about some of the challenges, because we can create different products from processed byproducts, right? So instead of maybe, for example, giving it on and putting it in the landfill, we can use it to make our products, like in the case of scrap bread samples. But there may be some issues like consumer acceptance. Consumers may not want to consume those types of products, so there are several challenges associated with it. And costs are usually higher for these types of products because of the added cost due to the processing or additional steps. So there should be policy incentives to incentivize the use of those. And then also there's some debates. There should be a minimum percentage of upcycled ingredients to be considered upcycled food, third-party certification necessary. Actually, there is a third-party certification right now called upcycled food certification that companies can apply for. So this is a huge opportunity for products that are normally going to waste, and then instead of putting them into landfill or maybe incinerate and generate energy from it, we can actually feed animals or people as the first option in the food waste recovery hierarchy. Thank you very much.
Wonderful. Thank you so much, Dr. Boz. Really appreciate that. And students especially, I hope you were paying attention there. That challenges slide, that's a good little portion of your presentation that falls in the rubric, and that's a really great way to get yourself ahead of the game there. So thank you again so much, Dr. Boz. Up next is Lynette Solway, who has studied civil and environmental engineering at University College London and holds a master's in environmental engineering. She's currently living in Chile, working as a director of technology, transfer, and circular economy for the Euro-Chile Business Foundation, where she coordinates various circular economy-based projects. Lynette led the consultant team that supported the Chilean Ministry of Environment with the development of the Chilean National Circular Economy Roadmap that was published in July of 2021. She also created and runs a circular economy working group aiming at supporting small and medium-sized enterprises, SMEs, in their transition to a circular economy. Again, thank you so much for being here, Lynette, and take it away.
Really exciting to be here. So let's get right into it. My presentation will, I think, complement nicely with Zinet's. I'm also going to talk about the food aspect. So now we've heard a bit about what the circular economy is. I want to go a bit deeper and talk about the bioeconomy. But before giving you a definition, I'd like you to try to guess what that might mean. And for that, next slide, please. I have a question for you. What do these products have in common? We have a t-shirt, a jacket, what looks like styrofoam, a plastic container, these coffee mugs, and a cup of and a bag of coffee. So what do you think these have in common? Please, next slide. Next, yeah, these are all bio-based products. What does that mean? They're all made from natural resources that are easily available in nature. So for example, the t-shirt is made out of cotton. This packaging that looks like styrofoam is actually a mushroom that you can make grow in a certain shape that you can then use for whatever you need it for. This bag of coffee looks like plastic, but it's actually made out of sugar cane. And the same for this plastic container you see down here, which is a PLA plastic, which is usually cornstarch based. The coffee cups are also a mix of cardboard and this bio-based plastic, if you want. And what looks like a leather jacket is a vegan leather made out of cactus. Next slide, please. And why is this all relevant to the circular economy? Well, the circular economy actually works with two different cycles. So you have the technical cycle, and most of the objects you have around you probably at this time makes up this technical cycle. So the computer, a fridge, your cell phone, these are all part of the technical cycle. But then on the other side, you have the biological cycle. So of course, in that biological cycle, there's everything you eat, you consume, but you'll also get, for example, if you have a wooden chair or a jumper made out of wool, that's also going to be part of the biological cycle. And why is that important? Because the biological cycle is what makes up the bioeconomy. And what's the definition of the bioeconomy? Well, it's the sustainable production of renewable resources from land, from fisheries, from agriculture environments, so from nature, and their conversion into food, feed, bio-based products, as we've just seen in the slide before, and bioenergy. Next slide, please. So now we're going to see some strategies that you can use to implement and well, that are really relevant within a bioeconomy. Zanette already mentioned some of these, but I'm going to go in a bit more detail into each one. So prevention, redistribution would be like the first actions you would take. And then once waste is actually created, you have 3 other strategies, which are making new food products, inputs for agriculture, and new materials and bioenergy. Next slide, please. So if we look at prevention and redistribution, here we have 2 examples where instead of throwing out these products that might not be exactly that might not meet exactly the requisites and requirements from the market, they've been marketed in the different ways. So for example, up top, you'll see these biscuits that are from a French company, my home country, that actually stopped throwing away their biscuits that didn't come out quite right from their production process and just started marketing them as ugly biscuits at a lower price, but same taste. And the same here for a UK-based supermarket, but you'll see it in many different places and maybe probably even in the US. These wonky vegetables and fruits. I'm not sure if you know, but usually most fruits that get to your local supermarket need to go through a beauty contest. So you have a lot of fruit that don't pass this beauty contest, and this is of course a way of rebranding and selling these and avoiding them going to waste. Next slide, please. In the case of making new food products, actually Zanette already mentioned some of these, but for example, you have these Real Good company, it's a Chicago-based company, they make fruit juices and they use the pulp from their juices to make these icicles. Toast was already mentioned, and Sir Kensington, I saw it there in Zanette's presentation as well, that it uses the water that comes from cooking the chickpeas and replaces the egg in this mayonnaise, and the Rin that also dehydrates different fruit-raised products into these crisps or chips. Next slide, please. Regarding inputs for agriculture, well, some of this waste food could go to feed animals, chicken, for example, but also black soldier flies or the larvae of black soldier flies that will then create compost, and actually you can then make protein out of this larvae, and of course composting as well, bringing the nutrients back to the soil. Next slide, please. And then you can also create new materials and bioenergy. We already saw quite a few new materials. Here you have the sunglasses, which frame is made out of a straw. The leather bag, or what looks like normal leather, is actually pineapple leather. And then down below here, you'll see it's a waste water treatment plant located in Chile, in Santiago, and it makes biogas, which is very similar to methane, from the waste we humans create from the sludge. Next slide, please. So we've got all these strategies. Now, how can we implement a bioeconomy or any other circular economy strategies within a country or at a larger level, right? So in a city, in a region, in a state, how can we do that? So that's one question we definitely asked ourselves while we were working on the circular economy roadmap for Chile. Next slide, please. And we defined, let's say, 5 main components. Next slide. So first, education. Education is key. From, well, primary, secondary school, up until university, technical careers. We really need people that know about circular economy in society. Next slide, please. And next and next. I think there's We also need cultural change. We need people to change their habits, the way they've been doing things. We need people that need to start recycling, maybe buy secondhand. So we need to implement and push for this cultural change. Next 2 slides, please. But then we also need solutions. We also need to make sure that if people change their habits, they also have the solutions that allow them to change their habits. And therefore, we also need research, development, and innovation. Next slide, please, or next 2 slides. And in order to push all these things, we also need to make sure that there are financial incentives. If everything that is more sustainable or circular is twice the price of more traditional products, of course, loads of people will not change their habits, will not go towards a circular economy because it's just not attractive. Next slide, please, or next 2 slides. But then fundamentally, another key aspect that we need is collaboration. We need all these, we need the public sector, the local governments, the national, well, the state governments, academics, we need the federal government, we need the companies, we need people, citizens, to all work together in order to make this change happen and to really be able to implement circular economy. And that's what we've been working on for the Chilean circular economy roadmap. And it's a long journey, but it's definitely, these are, let's say, 5 key elements, 6 key elements that are really necessary to look at when wanting to implement a circular economy. Next slide, please. So I just want to wish you good luck designing your own circular cities, and really also looking forward to seeing what you come up with.
Wonderful. Thank you so very much, Lynette. I think we're seeing some recurring themes about some of the challenges here in the circular economy. We're also definitely hearing some great solutions and great opportunities. So teachers, mentors, students, I hope you're really, really paying attention. And to round out our panel discussion is Ms. Denise Durant, and she is the engineering program manager for the standards division of Underwriter Laboratories, or UL. In this role, Ms. Durant is responsible for leading the advancement of scientific and engineering rigor in the development and revisions to the UL standards and standards initiatives. She also manages a team of diverse engineers responsible for supporting the integration and advancement of scientific and engineering topics, including emerging technologies across UL's standards portfolio. Relative to circular economy, the standards division of Underwriters Laboratories is developing a new standard, UL 3600, which is the standard for measuring and reporting circular economy aspects of products, sites, and organizations. This standard is intended to normalize methods, terminology, and level of transparency for measuring circularity, passing information between entities, and making claims related to material flows and their environmental impact. Thank you for being here, Denise.
Thank you, and hello, everyone. As Dan mentioned, I work for UL. If you've ever heard of UL, you know that we are a company, as you can see on the next slide, that's devoted to really driving public safety. So as you can see in today's overview, I'm going to talk a little bit about the work that we do at UL, how we develop these types of standards and documents, and then the work that we're doing in Circularity and UL 3600. So like I mentioned on the next slide, what you'll find is that UL, our mission is to develop products and systems and really ensure that the UL mark that these products and systems bear truly do make the world a safer, more secure, and more sustainable world. And I will say the word sustainable actually just got added to our mission about 3 years ago. So UL has recognized the fact that sustainability and circularity are truly important to the safety in today's world. So on the next slide, you'll also see that UL is comprised of a for-profit and a nonprofit side. I actually work for the nonprofit side of UL, but I started my career on the for-profit side. And the interesting thing about our organization is that From the for-profit side, we are responsible for testing, inspection, and certification, as well as advisory services for different types of products. So that's where we evaluate the circularity or the sustainability aspects of different products. And then on my side of the house now for the nonprofit area, I work in the standards division, and we develop the standards that are used now to address circularity and sustainable materials as well. We also have research and education and outreach to really help us figure out what research do we need to do to drive, our sustainability standards forward. What partnerships do we need to partner with other external organizations to help us make sure that our standards are, truly addressing the world's safety needs. And then from the education and outreach side, we want to make sure that we provide this information to people like you so that you understand not only the work that we're doing to keep the world safe, but you can also potentially be involved in how we develop standards. So on the next slide, I'm actually going to talk a little bit about how we develop a standard. And really quickly, the phases of the process start with, a proposal submission. And each one of these phases is processed utilizing one of our online, what we call a collaborative standards development system. So typically what happens is someone will submit a proposal. They'll say, I think we need a standard in this area, or for your existing standard, UL, we think you need to revise some content in this manner. And the next phase is a preliminary review. That preliminary review actually goes out to not only stakeholders who are involved in that industry, but also to people like you who are interested in learning more and contributing to that standards development process. It goes through a proposal review, it's voted on, and then not have what we call that, goes back to regulation or back for public input. I think the important piece here, our process.
Excuse me. Oh, Denise, I'm sorry to cut you off there. You
Yes.
started to fade out there at the very end of that. I'm sorry. Would you mind repeating that, like the last sentence, if you don't mind?
Yeah, I'm sorry about that.
No, it's okay. You sound great now, but thank you so much.
Okay. So the important things here, our process is open. It means that anyone can apply to be on an STP, what we call a standards technical panel, which oversees that standard. It is transparent, where all of our information relative to our standards development process is available for access. Market relevance and effectiveness, that's something that my team really helps to drive, because we want to make sure, again, that these standards are truly addressing the world's safety issues. Our standards are also coherent. And what we mean by development dimension is that we don't just make a standard just to make a standard. We make a standard, we also maintain it to make sure that it continues to stay relevant as well. So now I'm going to switch gears a little bit, and not to repeat some of the things that Dr. Boz and Ms. Solway said, but in terms of circularity on the next slide, what I want to point out that's most important here is, next slide, please. What's most important is that from a standards development process, we know that the market is evolving. We want to make sure that we can truly measure circularity, and that's why we're developing a standard in this area, because we want to provide that complete picture. We want to make sure that different organizations can measure circularity for their products. And so on the next slide, you'll see that there are a lot of different words that are used to describe that circularity measurement concept. Everything from downcycling to pollution to energy, reuse, design for circularity. Even within the electrical engineering, electrical safety kind of realm, circularity is an issue that they're trying to address at the regulation level. They know that different products, I'm sorry, you guys can't hear me?
Okay. Sorry to cut out a little bit again there, Denise. Sorry about that.
Okay, sorry about that.
No, you're good again. Great.
Okay, so just on this slide, really quickly, I listed a few circularity measurement concepts. And the reason being is that there are so many different words that are associated with circularity, everything from downcycling to pollution to energy. And even within the electrical safety realm, we're finding that even electrical products have a circularity component. And so on the next slide, we're going to get into a little bit of how we look at circularity from a company view. We look at it from a take, make, and waste perspective. And this kind of goes back to what Ms. Solway was saying in terms of prevention. I think she actually showed the same image. So we want to look at this from the standpoint, and you can keep clicking for me. We want to look at this from the standpoint of making sure that we look at the complete life cycle of a product. And then on the next slide, we have a couple of standards right now that truly fall under the circular economy kind of category, but the new one that we are developing, UL 3600, is truly going to revolutionize how we view circular economy. All right, are you guys able to still hear me?
Yes.
Okay,
You're there.
perfect.
Thanks.
All right. So on this slide, what you'll see is we want to look at circularity not only from a facility or site level, but we also want to look at it from a product level. So we have, like I mentioned, several standards right now: recyclability, recycled content, repurposing of batteries, that all fall under that circular economy kind of realm. But as I mentioned, on the next slide, what you'll see is that UL 3600 is our new standard that's truly going to express circularity by providing a clear way to measure and report progress towards circularity at the product site and corporate level. And that's what you see here. This new standard is really going to take the approach of helping us measure and report circular economy aspects, which is the first of its kind. So as you all are going throughout your project, one of the things that you'll find is that there's not really a standard or any kind of guidelines out there right now to help report, the circular economy aspects of different things. And this is something that we're working on. I wish the standard was going to be published and available for you all to use right now, but hopefully soon it will be. So what you'll see on the next slide is that relative to the development of this standard, we've gotten input from several different areas. We've got standards technical panel members, again, that consensus body that develops the standard. We've got members from producers, people like Dow and Eaton, from organizations like the American Wood Council, from supply chain, from commercial and industrial users, and also from government. And so on my last slide here, some people ask us, why UL 3600? Why is this important? And the reason this is important is because this, again, is the first standard, performance standard and safety standard of its kind that's really going to help us combine the aspects of circular measuring elements, truly understanding the difficulties that exist right now with identifying and measuring circular economy. So like the slide says, the concept is simple. We want to be able to know once a material is harvested, it's made into a usable product, it serves its purpose and returns to a material or component. How do we measure how it's to be used again or how it will be used again for a new purpose? All right, so thank you.
Fantastic. Thank you so much, Ms. Durant. Really appreciate it. That was great. All right, so now is the time for everyone to ask any questions that they haven't already submitted. I see that we've got a couple, so I'll direct those to the panelists. But if anybody else who's watching has any other questions that came up, now is the time to put it in the Q&A box. Charles asks, this is maybe for everybody on the panelists, anyone who feels like jumping in, does a pandemic affect a circular economy differently than a linear economy?
I can jump in and provide a little perspective on that.
Excellent, thanks.
And what I will say is what we're noticing right now from the standards development side and from some of our research teams is that when we're truly trying to, evaluate circularity for different types of products, our standards have to be very clear about, how different components and different materials are sourced, for example. So everyone's probably seen in the news right now that it's difficult to source different products and materials from other countries because of the pandemic and transporting those products across waters, through railway, so on and so forth. So the pandemic is really right now influencing how different subcomponents, different materials, raw materials really are being used in a lot of different products, which means that for our standards, we have to be very clear about how we evaluate different products, as well as what requirements the standard has for, alternatives that you can use within a certain product, to make sure that the circularity aspects don't change.
Excellent, thank you. We also have a question. Someone asked, do you think public transportation would reduce emissions in the future? And how would public transportation fit into the ideas of a circular economy?
Well, maybe I can jump in here. I think, well, first of all, I think that's a really great question for you to also think about when you're designing your cities, right? But yes, definitely. I mean, first of all, public transportation, I don't know how it is in the US, but here in Chile, at least, it's moving quite fast towards sustainable, renewable energy. Buses, for example, using the metro and the metro being powered by renewable energy. So you definitely have a much higher capacity to transit towards a circular economy in that way. Also moving more people with less energy. But I'm sure there's loads of other alternatives. I mean, for example, all the scooters, shared bikes, shared cars as well are definitely a really good way of not only lowering the emissions of the vehicle itself, but also the emissions and all the environmental impacts linked to the production of, for example, the car.
Excellent, great, thank you. Jackie asks, are new engineering segments or professions or fields emerging from circular economies? And if so, what types?
I would say absolutely. Right now, I just hired for my team specifically someone with a little bit of a background in sustainability and circularity. So that person actually has a degree in environmental engineering as well as material science and engineering. And the program that he was enrolled in and graduated from, the focus and the focal point was on sustainable practices. So I would say that is definitely a new and emerging area within academia that at least I know when I was in college did not exist.
It's exciting. One student asked, what is byproduct synergy?
So I can take a stab at this one.
Great.
I know for us at UL, when we're talking about different products that are used in series, for example, the byproducts that those the byproducts that are released, for example, and when we think about emissions, those byproducts that are released, we're trying to figure out what is the impact to safety and performance to other people and products and systems around it. So in one case, one of the research areas that we have right now is looking at CO2 emissions for truck drivers, because we know for a lot of different truck drivers, they're sitting at a truck stop, fueling up, and they're doing so with their truck, still kind of idling. And with that, all of the different materials that are used on, and this is a very specific example, so I hope this helps you understand your question, but if not, please let us know. But for this specific example, with truck drivers, what we're noticing is that because they're sitting at a truck stop, and that truck is releasing a lot of CO2 into the air, potentially back into the truck, we're trying to figure out what are the emission safety concerns that would exist for, inhaling that. Also, what happens when other products that are within the truck, for example, some of the lithium ion batteries, for example, what happens when those come into contact with a lot of CO2, how all of those different byproducts influence the safety and the performance of not only the people that are in contact with it, but the other products and systems around it. So that's one very specific example that I can share relative to how we look at byproducts and the importance of understanding how they interact with each other from a safety standpoint.
Excellent, thank you. The next question is from Sarah, and it's for Ms. Solway. How do you know which products go through the biological cycles versus the technical cycles?
Yeah, perfect. Products within the biological cycle are products that you should be able to reincorporate within nature. So you could technically just throw it out into nature and it should decompose. I'm saying theoretically because some of these products require specific conditions like heat, humidity conditions that would make it degrade faster. But it's basically, let's just say they're using, it's a product that is made out of the same components, the same building blocks as nature is. Whereas, so for example, the food you eat, as I was saying, a cotton t-shirt, cotton is a plant, right? A woolen jumper, because wool comes from sheep, and so you could theoretically just leave it out in nature and it should biodegrade naturally. Whereas in the technical cycle, these are not products that you could just throw out into nature. Those are the products we're having trouble with right now, especially regarding plastics, when they reach nature, especially, for example, seas, oceans, right? If you throw your computer or your cell phone out into a forest, you will come back in 100, 200, 500 years, and it will still be there. So that's the main difference. One will break down and will become feed for that ecosystem, whereas the other one will just contaminate it and not break down at all. I hope that makes sense.
Excellent, thank you. We have another question for any of the three panelists. They ask, any particular waste that you see needs more attention currently? Is there anything particular that is especially time sensitive for us at the moment?
I can actually jump in on this topic, and it's packaging, definitely plastics. Packaging, because of its plastics packaging and single-use packaging, because of its environmental impact, and not just environmental, but the ecosystems and the animals and the ocean. And it's so visible. Because of that, people actually blame packaging, even though we need packaging from a food loss and waste perspective, because it has a function. So maybe finding a balance between those is definitely a go-to route for us.
Excellent. Another student asked, can you talk a bit more about what closed loop means exactly?
Well, I can maybe start, and then maybe my co-panelist want to complement. But basically, a closed loop means that no material that enters the economy, so everything we extract today from nature, especially from the technical cycle. So here, that's why also it's very important to make the difference between biological and technical cycle. All technical materials that enter today's economy, so metals, plastic, any other fossil fuel-based materials, and well, a bunch more chemicals and etc. materials. You have to make sure in a closed loop that that material will circulate infinitely within the economy. So each time the product that that material is making ends its use, that it is then reused to make a similar product or a different product, but that it remains in use, let's say, forever, and never ends up in a landfill. Whereas, for example, if it were a biological product, then actually it's fine that it goes back into nature, because then it becomes nutrient and feed to the ecosystem. But for example, we want the metal in your cell phone, or most parts and products that make up most materials that make up your cell phone, that they remain in use for hopefully forever. And that's closing these loops. It's really this idea of well, looping around the materials. And I just want to take this opportunity to tell you all that I really recommend you go and check out the Ellen MacArthur Foundation website. They have loads of materials, videos, case studies that can be really, really useful for your work and to understand better what the circular economy is about.
Thank you. Anyone else have anything to add on about closed loops?
I can say so. There are two different closed loops. One of them is true closed loops, where you can actually almost make sure that you're actually closing the loops, like stadiums. For example, when you're consuming a like, let's say, like a drink, like a soda, and then they give you PET based cups, and then you're not actually taking them with you to your home, right? You just dispose them in a stadium during a game, instead of versus, for example, a cup that you get from a festival area or some let's say like a coffee shop. You're taking it with you, right? So you're not actually disposing them at locations that are convenient for those organizations or businesses to close the loop and recycle, for example, right? So and then there's a difference between those two. And then of course there's several practical challenges related to those, and one of them is called closed loop, actually, versus the other one is just closing the loop, not the closed loop.
Excellent. I think we have time for two more questions. Would buildings made out of recycled items be reliable? And if so, how are they? How do we ensure that they are reliable and safe and sturdy?
So maybe I can just quickly chime in.
Mhm.
In order for recycled materials to be used in the buildings, they need to meet certain standards, right? There's several standardization organizations that are ensuring that those materials are good quality and then reliable. So it wouldn't be a problem if it's approved by the regulatory organizations, for example, if it meets the ASTM standards, right?
Yeah, and I'll just add that the regulatory piece is definitely important, because regulators and building codes, the codes are really the regulation that's involved. The code is going to require, for example, a building code would require that those materials be certified or at least tested to those very, component level ASTM type of standards, for example.
Great. So I think I said this before, but I think we now have time for two more questions. So Leslie asks, what type, this is for Mr. Rand, what type of engineering degrees do people have or do people need to work at UL?
Well, so we hire all different types of engineers. I would say, 15 years ago when I started at UL, it was primarily electrical and mechanical engineers. I was one of the few that had a materials and chemical engineering background. But I will say in the last probably 7 or 8 years, we've really expanded to look at other areas. So more chemical engineers, more environmental engineers, even more civil engineers, as like I said in the previous question, we're trying to understand infrastructure and different building codes and building requirements. So I would say at this point, UL is truly open to all engineering majors. We're really trying to figure out how to even bring in computer scientists and computer engineers, because now, everyone's familiar with cybersecurity and the impact of cybersecurity and the Internet of Things to different products. We're trying to understand that as well. And we need that expertise to kind of help us get there.
Great.
Great question.
And so for our last question is directed to Ms. Solway, but if anyone else feels like answering afterwards, feel free to hop in as well. Sarah asks, are there examples of cities or communities around the world that are leaders in implementing circular economy principles that students might research to collect ideas or learn about what their challenges currently are? So including or beyond Chile, which you talked about a bit, Ms. Solway, could you tell us a little bit about what else is going on and what the sort of future may look like in cities and communities around the world?
Yeah, of course. Well, in general, in Europe, quite a lot of cities are quite advanced. You have actually circular economy roadmaps at the city level in different parts in Europe. As a country, the Netherlands has actually pledged to become 100% circular by 2050. So you can also have a look at how they plan to do that. And once again, here, I would really recommend you check out the Ellen MacArthur Foundation website, because they have loads of examples of circular cities. Actually, one of their focus areas are circular cities. So I'm sure you'll find loads of material there. And you also have, I don't exactly remember the name of the initiative, but you have a bunch of cities in Europe that also a couple of months ago pledged to become circular in a distant future and signed the pledge. So you might also find information about those circular. I don't exactly remember. I'll try to look for it while we're still discussing to send you the link.
Excellent. Well, thank you all very much. Excellent questions and excellent answers. If anyone if we didn't get have time for anyone's question, feel free to send it to info@futurecity.org and we'll see if we can respond. I want to give a big thank you to our amazing panelists and to Mr. Dan Koval for hosting the program. I hope you all really enjoyed the webinar and found it helpful as you're working on your cities of the future. Don't forget to please complete the short survey that's going to pop up at the end of the webinar when you exit out. It's only 2 questions long, and it's very helpful for us as we plan in the future. Also, we'll have a couple bonus interview episode videos with other subject matter experts on circular economies. The links to these will be included in the follow-up email with this program's recording, which you'll get in the next day or 2. And you'll also be able to find them on Future City's YouTube page shortly. And the link to that is on the homepage of futurecity.org. Lastly, as always, you can send any questions, as I mentioned, to either your regional coordinator for questions specifically about the competition, your local program, or to info@futurecity.org for general programmatic questions. Thank you very much, everybody. Have a great day and good luck with your future cities. Bye-bye.